Hello, welcome. This is a C3 video on Trigonometric Identities. Okay, so them ones on the board there, I've just sort of left them for you to have a quick look at. You should be fairly familiar with them. I'm assuming, this is where I'm assuming your knowledge is at the moment. Obviously, you know the sin x over cos x equals tan x, etc. And there is a few more that I haven't put on the board. Such as cot x and cosec x and sec x, but I'm assuming you know them as well. And they're the main ones. So that sine squared x plus cos squared x equals 1. We're going to be going sort of off from that after we've learnt the first part. So that's one of the main trigonometric identities you need to keep in your head, essentially, is what I'm trying to say. Okay, so let's get started then. In this video, obviously we'll be doing trigonometric identities, but for the start half or first bit of the video, we're going to be talking about addition. So so your sine A plus or minus B, and your cos plus or minus B, and your tan plus A plus or minus B for all of them. Sorry, I don't know where mine's going there. Okay, so I've sort of said the three main ones, but what does that actually mean? Okay, so we'll start with the first one. So cos A plus or minus B, and that is equal to cos A cos just did this a second ago as well. Sorry about this one sec. Yeah, I thought it was cos A cos B. I'll explain why I forgot it in a minute and the way I try to remember. At least try. But the main thing to know is it's not, crucial that you remember these because you're given a new formula booklet anyway. So that's why I'm not going to spend too much time on why I've included the other part of the video is a bit more important. So plus or minus sine A sine B. Okay. So the other one, so sine A plus or minus B. And you should know that is equal to sine A cos B plus or minus cos A sine B. And I say you should because it's just on your formula sheet. You tan A plus or minus B, so you tan A plus or minus B. You should know that is equal to tan A plus tan B. As I said, these are in your formula sheet, so if you forget them, so right, over 1 take tan A times tan B. So the way I try to remember, I used to try because I didn't do it so well at the start, is because in the cos rule, you have, it's A and B of cos plus or minus sine of A and B. So the sines and the coses together on two sides of two parts of the addition. And then your sine rule, you've got your sine and cos together, and they're always corresponding with each different letters. So if you have sine with cos, you don't have two A's, you have an A and a B, so it's sine A and B, or cos A and cos B. It's cos A and sine B. Sorry. So basically, with the sine one, it's the opposite of the cos, where the cos, it's the two coses and two sines together, whereas the sine, it's the two different, so the cos and the sine with the two different letters as well. So hopefully that makes some kind of sense. But as I said, these are on your formula sheet, so you don't need to faff around with that. Your tan, well, the tan is obviously the one that's different. There's one you might not remember. Obviously it's tan A plus tan B over 1 take tan A times tan B. Now, I'm not going to go into too much detail. I'm just going to get through what I'm going to do in this video is I'm just going to get through the bit of the theory, and we'll do some questions afterwards. So, hopefully I'm assuming you're okay with that cos, sine and tan. I will go through a few questions, but the key rules and formulas are in your formula book, so I'm not going to go around and faff around with formulating them. Okay? Now the next part of it, part of the rule, and links to the cos squared x plus sine squared x equals 1 that I was linking to, is coming up with double angle formulae. So basically what this means is in these three, so 1, 2 and 3, in these 3 rules that we've got, the addition rules, they've all got A and B in there. Well, the double angle, obviously double angle, so 2 the same angle, that is going to mean we let B equal A. So what that says is everything, everywhere we've got sine A, that's going to stay sine A, but when we've got sine B, that's going to change to sine A, even though we've already got sine A there. So, talking about sine A, so we'll do that. So sine A, now A plus A is 2A, so we do sine 2A. Obviously this could be X's and Y's, whatever you want it to be. Generally in your formula book it's A and B, so that's why I'm keeping it as that. So sine 2A, so we put, where we've got sine A, we leave that as sine A. We don't need to change that. However, where we've got cos B, we need to change that to cos A. So cos A plus or minus. Now we've got cos A and sine B, so cos A remains the same. However, sine B changes to sine A. So that's what sine 2A equals. However, your cos 2A is slightly different. Oh, sorry. I'll go over how to simplify sine 2A in a minute. So cos 2A, the same sort of thing, except we've got, whenever we've got B, we put A, so it's cos A times cos A. And I'll simplify both of these in a minute. They can be simplified, so if you want to have a go at that while I'm doing it, you can do. It's plus and minus. Sine, when we've got sine A and sine B, we change the sine B to sine A, and we leave the other sine A's what it was. Okay, and then we've got tan 2A. Now tan A, you should know is tan A times, sorry, I don't know where mine's going there. Tan A is equal to, tan A is equal to tan A plus, tan A plus or minus B is equal to tan A plus tan B over 1 take tan A times tan B. Don't know where mine went there. So if we change everything to tan A, or if it wasn't already tan A, we're changing it to tan A. So what we've got, we have tan A plus tan B, so that's tan A plus tan A now. And over 1 take, now we're going to simplify this straight away. We put tan A times tan B, so it's tan A times tan A, which is tan squared A, which gives you an insight onto what we might do for the rest of them. That's why I left tan 2A to last. So we can simplify sine 2A. This is a good way of doing it if you forget the rules, by the way. So you've got sine 2A, so we've got sine and cos A and sine A. So what we can do is, because we're adding all these together anyway, or taking them together anyway, sorry, one sec, just so 2 sine A cos A, that simplifies too, because we've added 2 sine A's and 2 cos A's, so that all goes together. Now for cos 2A, what we've got is we've got 2 cos A times cos A, which is cos squared A, and sine A times sine A, which is sine squared, plus or minus sine squared A. Okay, we could rearrange these in different ways. So sine 2A could be, right up here, sine 2A could be, so just make sure I get this the right way around, or mess it up. Oh, right, yeah. Sorry, I need to introduce something first. Okay, so, well, not introduce, mention it. So remember the sine squared A plus cos squared A equals 1 over sine squared x plus cos squared x equals 1. We just simply, we've got these 2 formulas here, we simply substitute them in into them 2 formulas that we've got above. So sine A equals 1 take cos squared A, and we simply substitute that in to 2 sine A, and we can change the formulas there. But the key bits really of the sine 2A is 2 sine A cos A, and the main bit of cos 2A is cos squared A sine squared A. And obviously we can rearrange you've got your cos squared a plus, sorry, it should be sine squared a. So you've got your cos squared a plus sine squared a equals 1. I can rearrange that and then put them into the corresponding formulas there that we've simplified. So that's the main bits of it really. So just to recap there, so the addition formula you've got in your notebooks. So cos a, it's pen annoying me. So you've got your cos a plus or minus b, and that equals your cos a times cos b plus sine a times sine b, and then you've got your sine rule, your sine a plus or minus b, and that's your sine a cos b plus sine b cos a. And then you've got your tan rule obviously, so it's tan a plus tan b over 1 take tan a times tan b. And if we wanted to make it a double angle, we just change everything that in them equations to a, and we could just, that's the main part of it really. And then we can simplify them down, so if you forget them rules, so these two rules here, they're not in the, so the 2 sine a cos a and the cos squared a sine squared a are not in the formula book. So basically, if you forget them, we've got enough information in the formula to be able to adapt it, and that's the main why I don't necessarily remember it. Try to, but if you can't, don't worry about it, because you've got the basis there to be able to build on it. But save yourself time in the exam, I'd recommend revising that. Okay, so that's the main gist of it there. Okay, so what we're going to do now, hopefully I'll just give you a minute now to copy that down. Oh, no, sorry. Just give you a minute to copy that down, so that when we come around to doing the questions, you've got all the information you'll need. And don't worry about me, I've just got down a separate sheet of paper somewhere else. Okay, so just a few seconds. Right, okay, hopefully you've copied them down. We're going to rub them off and then we'll do some questions. There's only, so if you're up to where I'm putting it up now, I've only got a little bit left of C3 to do, so just to let you know how far we are. If you're in my book, so far we are up to the end of exercise 7.5, and then the next video after this will be solving equations in the type, so basically page 62 if you're in my class, and yeah, so you've got your Trigonometric Identities on that page. Solving equations is basically what it is, and then that's pretty much it. So we've only got one little short video after this and we're done. The main part has been the addition bit and the double angle. One thing I must stress as well about the double angle is when you've got sine 2a, if you've got sine 2 times the angle of something, you double the range of it's 0 to 180, it's 0 to 360, because 0 times 2 is 0, and 180 times 2 is 360. So that's, but generally that's if you're solving it in the cast diagram. But generally just ask what is tan A or tan B or whatever, which should be fairly obvious from the rules you just imply using the booklet. You know, the tan A plus or minus B, and we just use that rule for that. Hopefully that makes some kind of sense. If it doesn't, I'm going to explain it now. Okay, so what I'm going to plan to do now is do a few exercises through this book. So I'm going to leave out, if you're in my class, I'm going to leave out exercise 7.2 purely because I don't think it's that effective. And it's not really related to this, what we've been doing today. So I will put it up as another video, but for the moment I'm just going to focus on the questions that are on exercise 7.4 if you're in my class. If you're not, and I've just been going on, don't worry, we're just going to, I'll tell you the questions anyway. So it says, without using scientific calculator, so basically without using a calculator, use the addition formula to help find the exact value of sine 135 degrees. Now normally we wouldn't be able to do this. But because we know our rules, then we should be perfectly fine. Okay, so what are our three rules? well, our sine rule is sine A plus or minus B, and that is equal to sine A cos B plus or minus sine B cos A. Okay, so because we don't have a B, we're just going to do sine A plus cos A. So that's just sine of 135 degrees plus cos of 135 degrees. I think that's right. 1 sec. Just going to double check. So just give me a second. So don't want to give you the wrong answer. So exercise 7.4, question 1A. Oh, sorry. Forget that, suck that. Did that wrong. If you spotted how I did it wrong, give yourself a well done, because I messed that up. So what it's asked us to do is to break it down. And what I should have spotted straight away, it says without using scientific calculator. Now, what I was trying to do was, I was trying to make a bit of a mess of it, to be honest. So, what sine rules should you know the top of your head? Well, you should know sine 90 and sine 45 degrees. Sorry, that's not plus, that you should know them. Which obviously, being a mathematician, I don't. You should know. So sine 90 is 1 and sine 45 is a half. If sine 45 isn't a half, I'm going to write an idiot. Is it? Sorry, root 2 over 2. Okay, so that's what them two equals. And 90 plus 45 equals sine 135, so sine 90 plus sine 45. Because I was right before, I wasn't completely out of the mix. We don't have a B, we just have an A, so it's just sine A plus sine B. Sorry. Sorry, and then the other way around, for God's sake. Oh, sack this video. Hello. What it may not, obviously, now it seems a bit conjoined for some reason. Basically, I did a little bit more work on the addition formula and found out, well, not found out, it's the wrong word to use, got to tell you something. Okay, so, in the addition rule, what I didn't say is A and B, it isn't two separate angles, so you wouldn't get something like this. You wouldn't get sine of 60 plus 20 degrees and say solve that. That's not what it'd say. It'd say something like solve. So if we go back to our original equation, hopefully I've got rid of my error, but I'll put it in the outtakes. So solve 135 degrees. What we should, well, without a scientific calculator. Okay, so what will you need? Well, you'll need some triangles. So what you should know is you should know the 30, 60, 90 triangle. And you should know the hypotenuse of that triangle is 2. The height, so the opposite to 60 is root 3. And then the 60 to 90 is 1, has a length of 1. Okay, so if this is not making sense to you, this is what we use. So you just have to remember it. And then the 90, 45 and 45. And then the hypotenuse on that is 2, and the other two sides are 1. Okay, and then obviously back to year 9 stuff, we'd use the socket tower to work out what the angles would be. Sorry, we'd use like sine 90, obviously sine socket tower, so opposite of hypotenuse, and that'd get you, sorry, year 90. I need a drink in a sec. Time up there, one sec. Look, long day, never mind. Okay, so one questions could say solve sine of 135 degrees. And you should always be able to make whatever angle it gives you up out of 60, 30, or 90, or 45 degrees. Okay, so can we make 135 from 30, 60, 90, 45? Yes, we can. So what it is, it equals sine, sine of 90 plus the sine, don't know why my sines have an extra long part of the n on them, sine 45. So 45 plus 90 is 135. So we've got our A and B here. Okay, so sine 135 equals sine 90 plus sine 45. I've just wrote it in the bracket there of sine, and we'd use our addition rule, which we know is sine A plus or minus B is equal to sine A cos B plus or minus cos A sine B. Okay, and we just simply substitute them into there, like so. So it'd be sine A is 90, so it'd be sine 90 plus cos B, so cos of 45, plus, because we're adding them, cos A, so cos 90, times, sorry, oh, should be, so sine 90 times cos 45 plus brackets cos 90 times sine 45. That's happening today. So that's how you'd work that one out. So if we put that in our calculator, so sine 90 is 1, so 1 times cos 45 root 2 over 2 plus cos 90 which is it. So remember our thing of SOHCAHTOA, so SOHCAHTOA. So obviously for the cos we'd be focused on the adjacent and the hypotenuse, and it's 90, so we're at that point there, and up adjacent over hypotenuse, so there's the one next to it, so just work out cos 90 and you times that by sine of 45, so the sine opposite over adjacent says 2. So one sec, let me make sure I've got the answer that correct. So it's 7.4, question 1. So that's just root 2 over 2. And that's because cos 90 is 0. So it's 1 times root 2 over 2 plus open bracket 0 times 2, and that gets you root 2 over 2. Okay, so hopefully that makes some kind of sense. So we're just going to do Next question. So, exercise 7.4, question 2. Sorry about that. You are given a calculator in a C3 exam, so you don't necessarily need to worry about them triangles. Okay? So, question 2 of 7.4 says, given sine A equals 4 over 7, find the exact values of cos A and tan A. So what rules can we use here? So we know sine. Sorry, let me double check. One way to get A. So obviously we could let me just check this works. Inverse of sine 4 over 7. That 34.8. Sorry, you just have a go at this while I'm going to go at it as well. Sine inverse of that. Cos of that. Right, one sec. Alright, okay, so sine A, just double checking I had it right. So sine A, obviously to get A we do the sine inverse of 4 over 7. And that gets us A is equal to 34.8 degrees. So that's A. And then we just simply substitute it into these two values. So cos A equals the cos of 34.8 sec. So put that into your calculator. So I'm just going to 4 over 7. Sorry, I'm just getting the answer back on my calculator so it can be correct. Because of that should be root 33 over 7. Yep, which is 0.82. The reason I stopped there because I thought that was a little bit too easy. But then you do the same again for tan. So your tan of 34.8 degrees should get you 0.69. So there's your answers to question 2. Sorry about the weight there. Just doing it off the top of my head now. So I've normally I do these before, but just thought I'd be a risky kid. So anyway, question 3. So if you want to have a go at question 3 for your math class. Okay, so it says, given that cos of theta equals 5 over 6, obviously, just for precaution, find theta, so theta equals the inverse cos of 5 over 6. I think this exercise 7.4 is a bit of a accumulation of the questions rather than just the addition formula that we've been using. Okay, so cos of 5 over 6, sorry, the inverse cos of 5 over 6 is 33.55 degrees, or 33.6 degrees, so that's theta, and it's saying find the exact values of, sorry about my writing, it's a bit awkward holding a calculator and that. So find the values of sine theta, tan theta, cosec theta, and sec theta. Now you should know there's the first two that you should get straight away. You know, tan theta, sorry, you know the angle for theta, so you just substitute for the first two, should get that straight away. So sine of 33.6, and if you want to pause the video now so you can have a go at the rest of them. Okay, so welcome back. Now for the first two, it's just the sine of 33.6, which is whatever that is. So if we do that, sine of 33.6 should get us 0.55. The tan of 33.6 should get us 0.66. So the first two. Your cosec theta, now you need to remember what cosec is. Cosec is 1 over sine theta, which we already worked out. Sorry, just a popular guy. Just to go on that. Classy as it is. Okay, so 1 over sine theta, we've already worked out what sine theta is, which is 0.55, so it's 1 over 0.55. If we work that out in our calculator, over 0.55. What we could do is we could do 1 over the sine of 33.6, but it's going to give us the same answer of 1.81. Is sec theta. Now, sec theta equals 1 over cos theta, which is 1 over cos of 33.6, which is 5 over 6, so it's just 1 over 5 over 6, if that makes sense, or 1 over 33.6 degrees, sorry, 1 over cos of 33.6, or 1 over 5 over 6, so 33, so, one sec, sorry, 5 over 6, 1 over that, going to be 6 over 5, and that is 1.2. So that's your question 2. So basically it said cos theta equals this. What sine theta, tan theta, cosec theta and theta. Obviously sine and tan, you simply just put the theta in there, just inverse cos to get theta and put theta into sine and tan. For cosec and sec, we just use that cosec is 1 over sine theta and sec is 1 over cosine theta, and inputted the numbers from there really. So that's question 2 out of the way. See what else they've got lined up for us here. Alright, okay, so it says you are given the value sine A equals 3 over 5. Find exact values, and cos, weird B thing, equals 5 over 3, so cos of B equals 5 over 3, sine of A equals 3 over 5. Use the addition formula to find the exact values of sine of A take B. Okay, so sine of A take B. So we could write this as, say you need sine rule, so it's just sine A times cos B, take away sine B cos A. Now we can do the first part of that equation straight away. We've got the information for that, but what we don't have the information for is sine B and cos A. So what we need to do is we need to rearrange these two to get A. So what is A? So A is equal to the inverse sine of 3/5. And B, you need to know what B is as well. B is equal to the cos inverse of 5/3. So if you work them two out on your calculator. So sine inverse of 3/5 is 36.86. And the cos inverse of 5/3. So the cos inverse of 5/3 so unless I wrote that down wrong. Oh, so 5/13. Sorry, because it would come up with a math error, so obviously didn't read it right. So the cos inverse of 5/13, should have known that straight away. You can't inverse an angle bigger than 1, and obviously 5/3 is bigger than 1. So that's 5/13 comes to 67.4 degrees, or 67.38, whichever you prefer. So that means we round this up to 36.9. So you can keep it to the same sig fig. And then we simply put these values in, so that A is 36.9 and B is equal to 67.4. That's equal to B. Okay, and then we substitute the values into this formula. So sine of A take B equals sine A, which we know is 3/5, times the cos of B, which is 5/13. Take the values we found out. So your sine of 67.4 degrees times the cos of 36.9 degrees, and then you do all of that as one big sum, and then that should get you sine of A take B. Okay, so if we put that in our calculator, so 3/5 over 5/13 times 5/13 gets us 3/13, and then we work out the second half of the equation. So sine of 67.4, and we're timesing that by the cos of 36.9, and that is 0.74. So 3/13 take away that answer, 0.74 is minus 0.51. So I'll just move out of the way so you can double check how we got that. Hopefully it's quite self-explanatory. Just going to double check we got the answer right. So that was question 3. Sorry. Oh, that was question 4A, sorry. I didn't realise it was part B to 4A. Part B to 4, so it's just 4A. Minus 33 over... Because in the answer book it's got minus 33 over 65, which is exactly what we got. I just rounded it up to minus 0. Well, down actually to minus 0.51. So hopefully that makes some kind of sense to you. Fairly quite sort of simple stuff that. So if you cast your mind back now to what we did about sine 2A and stuff, just keep your mind on your toes and stuff. I'm going to leave exercise 7.4 out of the way, the rest of it anyway, and just go straight on to exercise 7.5. Just because I think we've got the basics, I just wanted to get to that question there. So hopefully that makes some sense. You've had a minute to copy that down while I just get some food, add some food to keep you going. Don't forget to do that as well. Everyone needs some food. Okay, so exercise 7.5 in the yellow books. Basically what it says is, question 1, everything that we're doing in question 1, it says solve each of the solutions, so solve each with a range, and now this is not a function range, this is simply a range of 0 degrees to 360. And it said not including because we haven't got the little dashes under there. So that's why I said remember the double angle rules that we had before. So cos of 2x is equal, it says, to root 2 times sine x plus 1. Now if you remember, cos of 2x, or 2a or whatever you want to call it, we know, I'll just put this as a little star next to it, is cos squared of 2x take sine squared of 2x. Okay, so that says cos 2x is equal to that. So I'll just give you a few seconds now so you can pause the video to have a go at that. Sorry, one sec. Sorry. Before you pause it, if you've not paused it already, or if you have, I'll come back. I'm just going to write a few more questions down on the board here. Cos 2x plus 7 cos x equals 3. That's 1b. 1c, it says 2 sine squared x equals sine of 2x. So solve them between them, that range. So I'm just going to give you a minute now to pause the video, and so I won't jump up at you again for a few minutes now. So just give yourself a minute, and we'll come back in a minute. Right. Well, welcome back. As you can see there, they are the results of the questions. Now, the eagle-eyed viewers may even notice there's a question missing there, and that's not because I've completely gone insane, it's because I couldn't work it out. Sorry about that. I did try and contact someone else who couldn't work it out either, so we had a bit of trouble with that one. But just, I mean, I'm sure that is completely possible. And the correct answer, so 7.5 question 1, the correct answer according to this, I'll let you know, so it was 0 degrees, 80 degrees, 360, 225 and 315. Now when I did it, I only got 225 and 315 degrees, so that's not really good. So the rest of the questions though, I managed fine, they're perfect. Okay, so let's go through question B first of all. Now I've put the results in there because I'll know you just want to look straight ahead and completely ignore me if you want to, which is fine. But I'm just going to show you, talk through it, so I'm not having to write it up and mess it up at the same time, so I could just talk through it. Okay, so one of the things you need to know is cos 2x equals cos squared x minus sine squared x, and that's just from the addition rule and simplifying it down, which I showed you in the tutorial. And then we apply this into cos 2x here, and it becomes cos squared x minus sine squared x plus 7 cos x equals 3. And then what we did is we used cos squared x plus sine squared x equals 1, rearranged that to get sine squared x, times that all by minus 1, and then we put it in brackets. Sorry, we put it in brackets, but you times by minus 1, expand it, and that gives you cos squared x, take 1 plus cos squared x, plus 7 cos x, take 3, equals 0. Simplify that, factorise it, it becomes 2 cos x, take 1, brackets cos x plus 4, and then it's either 2x take 1 equals 0, or the other bracket equals 0. The other bracket didn't work, I don't know why. And then 2 cos x minus 1, cos x equals a half, cos inverse of that equals 60, and then you put that in the quadrant diagram, and you should get, what was it, 1b, you should get 60 degrees, and obviously that should be 300, so if you put it again, you could go round the other side and that would get you your 300 degrees. Okay, so that would just be, the only thing I didn't put on there was the quadrant diagram, but you can have a go at that. And it's simply 60 and 300 degrees. And I'll just, well, I'll sample it over here, but so basically what we've got in that question is x equals 60 degrees, so it's in the cos part, and it's where all of it's positive as well, so it sort of goes like that, and that's 60 degrees, and that's 60 degrees, and then to get to 60 and 300, that's 1, and then that is 2. Okay, so 60 and then 300, 60 take away 60 is 300. That's how we get our two results of theta equals 60 degrees or 300 degrees. Okay, so that's simplified that for you. So I'll just rub this out because we'll need this in a minute. Hopefully that's sort of explained it a little bit. Right, so 1c, 2 sine x squared equals sine of 2x, okay? So, we should know the sine of 2x equals 2 sine x cos x, and that's what we've got here. And we just put that into there, 2 sine x squared equals 2 sine x cos x, and what you do then is you want to get rid of this sine x squared, sorry, that's 2 sine x squared, and divide that both sides by sine x, get rid of the sine x on this side, so it becomes, and obviously that changes from squared to just a sine x, so that becomes 2 sine x equals 2 cos x, and that's the point where I got stuck for a few minutes, and then what I thought was, well, I need to get rid of the sine x and or this cos x. So what I did is I thought, okay, so we can't square it or anything, so we have to use the formula sine x over cos x equals tan x, and only one of them has an above that would cancel out, which is cos x. Obviously we could do the other way around, cot x, but then we'd only be putting in back 1 over tan x, which is a bit of a faff, so obviously we had to get rid of the cos x. So divide both sides by cos x, sin x over cos x, that becomes tan x, cos x over con x equals 1, but obviously because it's 2 cos x, it becomes 2, it's the same thing, so it's 2 tan x on this side because there's 2 there, and a 2 on this side because cos x cancel out and it's 2. So 2 tan x equals 2, tan x equals 1, so x equals tan inverse of 1. And again, I didn't draw it on the diagram, but then you should get cos is equal to 0 degrees, and, tan inverse of 1, I think it's 0, tan inverse of 1 is 45 degrees, sorry, not 0, and then you should get as your results 0 degrees, 180 degrees, 360 degrees, 45 degrees and 320. 225 degrees. Yeah, that's correct. So hopefully that's, obviously you do the same as I did before. I don't want to go through the quadrant diagram again because I already made a bit of a mess of it. So hopefully that's, sorry to get in the way there, hopefully that's helped you. And that's all for this video, you'll be pleased to know. But you can pause it now, well it's going to end anyway in a minute, but you can pause it if you want to copy them down, and we'll see you in the next video.